Hello students, welcome back to my channel. In this video, I am going to give you a brief lecture on respiratory quotient. So, we know that in respiration, oxygen is consumed. Similarly, carbon dioxide is released. So, the respiratory quotient is nothing but the ratio of the volume of carbon dioxide produced to the ratio of the volume of oxygen is consumed in the respiration. So, it is the ratio of carbon dioxide produced to the ratio of oxygen is consumed in the respiration. So, RQ is nothing but respiratory quotient is nothing but the volume of CO2 produced by the volume of oxygen consumed is nothing but respiratory quotient. So, it can be measured by an instrument that is nothing but Gannang's photometer. So, by seeing the RQ value, you can tell the type of substrate is being oxidized. So, substrates are nothing but they can be carbohydrates, they may be fats, they may be proteins, they may be organic acids. So, the value of RQ of a tissue is depends upon the type of respiratory substrate. So, if you know the RQ value of a tissue, you can guess the respiratory substrate because RQ value is unique for different substrates. So, let's see the RQ value for carbohydrates. If hexose sugars such as glucose or fructose are oxidized, the RQ value becomes 1 or unity. So, let's see the equation for carbohydrates. C6H12O6 plus 6O2 gives rise 6CO2 plus 6H2O plus energy. So, glucose. We can measure the RQ value by an equation nothing but the volume of CO2 evolved by the volume of oxygen consumed. Okay. By calculating this, you can measure the RQ value. So, let's see. So, in this reaction, the volume of CO2 is evolved is 6 by the volume of oxygen consumed. That is equal to 6 oxygen molecules. Okay. So, then the RQ of carbohydrates is becomes 1 or it is equal to unity. So, this is the RQ value for carbohydrates. So, let's see the RQ value for fats. So, fats are poorer in oxygen. As they are in more reduced state, they require more amount of oxygen for the respiration. So, thus the RQ value becomes less than unity. So, let's see the equation. C16H32O2 plus 23O2 gives rise 16CO2 plus 16H2O plus energy. So, we have to calculate the RQ value for this. 16 CO2 are produced in this reaction and 23 oxygen molecules are consumed in this reaction. So, the RQ value, so that becomes less than unity. Okay. The RQ value for fats is 0.7. Okay. So, the RQ value of fats is approximately 0.7. So, this is the RQ value for palmitic acid. So this is the palmitic acid. Let's see the RQ value for proteins. Proteins, they rarely serve as respiratory substrate. During starving conditions only they serve as respiratory substrate. The starving condition is nothing but if you don't eat for a long time, your body runs out of glucose. So then the body depends upon the stored fats and proteins. So then only proteins undergoes respiration. Okay, so the proteins are also very less in oxygen. They are also in reduced form. That's why they require much amount of oxygen for the respiration. So that's why RQ value becomes less than unity. So the value precisely range between 0.8 to 0.9. So the RQ value for proteins that ranges between 0.8 to 0.9. So let's see the RQ value for organic acids. So organic acids, they are rich in O2 and high CO2 is evolved in the oxidation of organic acids. So that's why the RQ value becomes more than 1. So let's see the RQ value for malic acid. C4H6O5 plus 3O2 gives rise 4CO2 plus 3H2O. So this is the malic acid. So RQ value is equal to CO2 by O2, that is equal to 4 by 3, that is equal to 1.33. So the RQ value for organic acids is more than unity, more than 1. Okay. So let's see the RQ value for oxalic acid. C2H2O4 plus O2 gives rise 4CO2 plus 2H2O. So this is oxalic acid. So let's calculate the RQ value. CO2 by O2, that is equal to 4 by 1. So that is equal to 4. So the RQ value for oxalic acid is 4. So that is more than 1. Okay. So let's see the RQ value for succulents. So succulents are showing a special type of photosynthetic mechanism, nothing but CAM pathway, crustacean acid metabolism pathway. So here the succulents, they have special type of stomata, nothing but scotoactive stomata. They open their stomata during the night. So that's why they consume CO2 and oxygen during the night time. Okay. That diffused CO2, there it converts into malic acid at the night time. That is stored in the vacuole. Okay. In this way, the oxygen consumption does not involve the CO2 evolution. So the RQ value for succulents at night time becomes less than 1. During the daytime, malic acid undergoes splitting. Then CO2 is released. That released CO2 is utilized for the photosynthesis. So in this way, there is no release of CO2 during the oxidation of organic acids or etc. in the succulents. So that's why the RQ value, there is no evolution of CO2. So CO2 becomes 0. So there may be the O2 utilization may be 3 or 4 or anything it can be. So the value becomes 0. Okay. So during daytime, the RQ value for succulents, that becomes 0. Okay. So this is about respiratory quotient. So by calculating the respiratory quotient or RQ value, you can tell the oxidized substrate. Okay students, thanks for watching.